Awesome. So thank you everyone for joining us today. We have Paul Falcone here and we have Yafa Finkelstein to present to you guys today. Just a reminder to please log this in your Engage app as an activity for points because it is a training webinar. And then Yafa, whenever you're ready to begin, go for it.
Great. Thanks so much, Ariel. Thanks, Trisha. Nice to meet everybody. My name's Yafa. I'm one of the product marketing managers on the CloudGuard team. And today we're going to walk through an overview of application security with CloudGuard, why application security is important, why it's really important that we talk to our customers, particularly those born in the cloud customers, about a modern approach to application security and of course, the checkpoint approach to application security, which is quite novel and very exciting and something which we've only taken to market a couple of weeks ago. So with that said, I'm guessing that this is not the audience who need to be reminded of Checkpoint's security pedigree. Of course, we're one of the largest global cybersecurity companies trusted by many Fortune 500 companies. And you may be aware recently of the way in which we have consolidated our various offerings under the Infinity brand. So the idea is to provide our customers with consolidated, unified security. And of course, being a product marketing manager within CloudGuard, application security is part of the CloudGuard offering, which I'm going to talk to you about today. So again, this might be a diagram which many of you are familiar with. This is a depiction of CloudGuard, which is our unified cloud security platform. It's a cloud native platform. Many of you will know about Dome9, of course, which is now sort of our cloud security posture management component of CloudGuard. But the platform has many other capabilities, some of which you see here on the bottom are newer to Checkpoint. So there's what we've called workload self-protection, which includes security for containers and serverless functions, those things which power cloud applications. And then, of course, there's application security. So that's protecting web applications and APIs, both on-prem and in the cloud. And that's what we're going to be talking about today. So just to start off with, if you think about what your customers might be using at the moment to protect their application layer, so any applications, APIs, I'm talking about, websites, they will probably be using application security that's built on legacy AppSec. And what I mean by that is typically you would have something running called a web application firewall. Some of them may be legacy pieces of technology which have sort of these bolt-ons to make them more appropriate for the cloud environment. But essentially, the way in which they work is very similar. They'll have a very large table of attack signatures, and every time a request comes in, we'll have a look at an example shortly, but every time a request comes in, they will attempt to match the request against the very large database of threat signatures, and then take a decision about whether or not to allow that web application request. And what that means is they're making a very binary decision on very little information. It's just what they know already, which is that attack signature database. Now, this generates very high levels of false positives. There's a lot of work that has to go into calibrating a WAF. Every time there's an update to the application, every time there's a change in which users use the application, there will be an application security team often who are tasked with keeping the WAF up to date with the application. Now, when you think about the way that cloud applications have evolved, where you have DevOps teams with very short release cycles, constantly updating the applications, they're evolving quickly, they're growing really, really fast, and different users are using the application differently. And so modern applications need a modern approach to application security, and those legacy pieces of sort of static security just don't work in the dynamic world of web applications, cloud web applications. So what our customers will be looking for and what their attention should be drawn towards is the fact that they have these very dynamic, very fast moving, very fast evolving applications that are based in the cloud, and they're probably relying on application security, which is not automated. And as we know, we say this throughout our marketing materials for cloud, because this is definitely true. Everything that the DevOps teams are using is automated. And so your security has to be automated too. Otherwise, it can't possibly keep up. Now, I'm not just making that up. The consensus within the industry is that WAFs cannot, they're not fit for purpose in the modern application environment. They're just not cutting it. So that's why we've gone to market with CloudGuard AppSec, which is part of our unified cloud security platform. And we talk a lot about self-protection because I think it's a good way to describe how we're helping our customers to automate security so that every part of their cloud application automatically is secured from build to runtime. So these are the components of application security. And again, this is part of CloudGuard, right? So these are the capabilities that your customers will get if they decide to take application security with CloudGuard. So of course, there's that first element, which is like a WAF, but considerably smarter and of course automated, and it's able to stop OWASP top 10 attacks and other very sophisticated attacks against the application layer. We also have a very robust API security piece, which is powered by 2 different engines and stops the misuse of APIs so as to prevent attacks against the application using APIs. And of course, excuse me, modern applications have increasingly large numbers of APIs, which means that your customer's attack surface will have grown considerably. So API security is a really important part of application security, which perhaps their legacy WAF won't be covering in any case. We of course have a bot prevention component as well, which stops automated attacks at scale against the applications. And Checkpoint has the award-winning IPS piece, which is also included in this solution. Now, what makes this solution so different and so effective and automated is what we call our contextual AI engine. And we'll dive into the mechanics of how that works soon. I won't make it too boring or technical. It's actually a really cool piece of technology, which is quite new to the application security market. So we're very excited by this, but this is basically the sort of secret sauce that allows the application security that we provide to be fully automated, extremely precise, and very importantly, has the ability to stop the very high generation of false positives that are generated by traditional WAFs. And we ran a very successful early availability program of application security. Perhaps some of you have worked on this with some of your customers. We actually put out a press release a few weeks ago, which had a number of testimonials from some very excited customers with some of them with very complex deployments. But across the board, what we can say after running a very successful EA program is that 90% of the customers run this solution in prevent mode. So they actually allow it to run on its own, which talks to the precise nature of the prevention. None of our customers have more than 10 exception rules. And actually, most of them have less than 7. Now, legacy WAFs tend to require much higher, we're talking close to hundreds of exception rules. So anybody who has any experience with application security will know that less than 10 exception rules is pretty cool. And because of the AI engine, which we'll have a look at in a few minutes, it takes just a matter of days to go from deployment to active protection. Now, this sort of automated capability, this sort of characteristic of the product is also extremely exciting, because typically a legacy piece of application security will have to sit and learn the application for a number of weeks before it is able to actively protect the web application. Now, when you think about, again, how quickly we're updating our web applications, every time there's an update, your solution has to learn that sort of delta, that new part of the application very quickly. So CloudGuard not only initially learns the application very quickly, but also every time there are updates to the application, it is able to learn those new components and how they're used very fast, so that we're going constantly from deployment to active protection with that sort of continuous learning. So it's very fast. Now, some of the use cases for this capability include preventing attacks against the application using APIs. So you can see here in the diagram, this is depicting, this is preventing web applications as your attack evolves. So this is the automated WAF use case. So you can see here in this graphic that you've got a user who's making a request of a web application, but before the request reaches the server, we have the contextual AI engine there, which takes a decision really quickly about whether or not to allow this request. We'll have a look at an example shortly. So it protects your web applications, and it also secures the APIs associated with those web applications. And it does that using a couple of engines. So first of all, we've got that same contextual AI that takes a decision, not a binary decision, but actually builds a risk score to decide whether or not to permit an application, a user request. But additionally, we have a tool for the development team so that the API schema files are automatically ingested. And this is critical because every time a developer writes their API schema files, they will describe how they anticipate those APIs to be used. And so by automatically ingesting those files and running a validation against them with every web request that comes in, we're able to say when a request comes in, whether or not it kind of meets how the developer intended the APIs to be used. So that's also pretty cool. And lastly, we are able to stop malicious bots by easily discerning between human and non-human traffic and stopping the non-human traffic from any of those automated attacks that you can see there on your screen. And that's powered by another engine, which is a small piece of JavaScript on the client side, which takes a decision quite quickly. So I keep referencing this contextual AI engine. So let's have a look at what it looks like. So this is really all about risk score building and how we're able to provide our customers with the ability to build what we've called self-protecting applications. Now, in order for their application security to be fully automated, they need these three key capabilities. So they need to know that the prevention is precise. And in our case, we have this contextual machine learning risk analysis, which has a look at all of the parameters around each web request in order to build a risk score. And this precise prevention provides two things. So first of all, it stops and virtually eliminates the very heavy number of false positives, which are typically generated by WAFs, but it is also able to identify sophisticated attacks against web applications. So there's sort of two parts to that precise prevention. In order for an application to be self-protecting, the security has to adapt automatically to any application changes. So as I mentioned before, CloudGuard is constantly profiling the users, the application and the content so that it is continuously learning and able to automatically protect any new parts of the application or change the way in which it understands how the application is typically used. And of course, and this is true for any security to be effective in the cloud, we have a number of automated cloud native deployments which are agnostic to any cloud, whether that's public or private. We have a variety of deployment models. So all of these different advantages of this particular capability of CloudGuard demonstrates how we're able to create self-protecting applications with our customers. So I'm going to just walk through a quick example of what this looks like in real life. So in this case, what you see in front of you is a web application, and this is a newspaper. Now, there's a developer who added a new piece of functionality to the web application. You can see that there's a search box there. And in this instance, this web application is protected by a legacy WAF. And I will say that this is actually based on a real example that we saw in the wild. Now, you can see here that somebody's tried to run a search on the website using the tool as it was intended. So this is a non-malicious user making a non-malicious request. There's some workers' union election that's come up, and we're looking to see who the chairman was. Now, those of you who are familiar with SQL attacks, and I have to be honest, I'm not one of those people, you'll know that the apostrophe, union, and select all happen to also be in SQL attack signature. So those together could be seen as SQL attack signatures. They are SQL commands apparently. And so in this case, the legacy WAF sees this non-malicious request and decides that this actually matches a SQL attack that it's seen in the past. And so it stops this non-malicious user from making a non-malicious request. And of course, this is not what we want from our application security. This would be a false positive and also provide very bad user experience. Now, that doesn't happen with CloudGuard because of this risk scoring that we take, and powered by the AI engine, and that is what this dial here depicts. And we're going to just look at how, if this web application was protected by CloudGuard, the same scenario with this non-malicious user making the same non-malicious request, the outcome would be very different. So we make that request of the web application, and the first thing that you must understand about this particular solution is that we don't just look at the web request in isolation. We don't just look at that database of threat signatures that your legacy WAF will be looking at. We look at a number of parameters related to that particular application request. And we start with a parameter which we call the transaction risk. And in this case, we can say that there is a possible attack indicator, being that, we have a database of attack indicators, including everything that you'll be familiar with in Threat Cloud. And so initially we will give this particular request a high score, but this is just the first of many parameters. So the next thing we look at is the user behavior. And of course, this is new. We say that if the user has made multiple requests, which in this case they have, all of which were benign, besides for this one. So you can see that in this case, there were 63 previous requests by the same non-malicious user, which were all non-malicious. It is very unlikely that one request is therefore malicious. And so we start to actually reduce the risk score based on that parameter, but then we continue on. And we have a look at the content risk, so the crowd behavioral risk, I apologize. So we look at the way in which this URL is typically used. And what we learn from looking at the crowd behavior is that this particular part of the application is prone to generating false positives. So something which perhaps may look anomalous in isolation is actually typical of the application's use. And we learn this continuously as the site evolves. And in this case, we say that actually this search bar has generated multiple false positives from other users. And so we reduce the risk score further. And then finally, we have a look at what we call the content risk. So this is the content itself. So we ask ourselves, in this instance, is the content which was put into this bar what we would expect to see inputted into this bar? And of course, it was regular text put into a free text box. And so this would be the typical kind of content we would expect to be inputted. So we reduce the risk score further still. And what that means is, once you look at all of the parameters around this particular request, this is most likely, according to CloudGuard, a non-malicious request. And indeed, in this situation, CloudGuard will permit this request. So the solution is available in multiple different environments. It's a very flexible cloud native environment. We have a variety of deployment options for different customers depending on their architecture. As I mentioned before, this is a solution which is available on any kind of cloud and any kind of architecture. As you would expect from a Checkpoint product, we have all of the visibility and analytics in a single unified dashboard. And just going back to those sort of proof points from earlier, so we said that this product provides very precise prevention, and that is illustrated by the fact that 90% of the customers actually leave this to run on its own in prevent mode because the prevention is so extremely precise. There is no policy administration. That is very unique in the world of application security, and none of our customers have more than 10 exception rules, which is an enormous feat. And of course, the solution can be deployed automatically on any environment with very few days from deployment to active protection, which again is quite a feat considering that most WAFs take weeks to go from deployment to protection. So in terms of your customers' next steps, we have free trials of CloudGuard, we have free trials of application security. Of course, we have plenty of information on the website and the opportunity to schedule a demo with any of the cloud security architects at Checkpoint. Just to get an understanding of the pricing, we have a variety of different models to support customers with different types of deployments. So for those of you who are perhaps more familiar with the workloads solution that we have, the workload security solution that we have, we're actually currently running an EA program for container security. But this can be purchased as part of workloads. It can be purchased as a standalone solution, and it can even be purchased as a pay-as-you-go model. Now there are a variety, this is the list price, there are a variety of different deployment options. So it's important to reach out to your SEs to figure out what would be best. Now, in general, when I've spoken to many people in the field and different checkpoint partners who have seen the way in which we have built this solution, there are three things which everybody sort of agreed upon. First of all, the automation is so valuable for our customers who are running their cloud web applications. The improved security with lower overheads is another thing which has made everybody quite excited. The price point is extremely attractive. It's very competitive. A lot of the legacy or perhaps competing solutions will charge considerably more per year than our pricing. And of course, as with anything within the Checkpoint portfolio, we're able to align to our customer business objectives. So this is not about taking a product off the shelf and trying to figure out how to use it. We typically will package up solutions that will align with your customers' business objectives. And as far as the partner marketing materials go, so it's a great time to engage with your channel account managers or SEs to hop on board and get some training, because come the middle of April, we're going to have a campaign in the box running for application security, which you'll be able to access. We have a lot of content, and the idea is to empower our partners to be able to run their own campaigns as easily as possible. So there'll be a lot of content. There'll be lists of subject matter experts that you can call upon, because by sort of towards the middle or end of April, you'll be able to set up your own custom webinars using that campaign in the box, talk to your Checkpoint counterparts to schedule some time with some of the experts who can help talk to your customers about application security. So we're very excited about taking this to market. And I guess at this point, we'll open up for any questions.
So this is a great presentation. I actually had a couple text questions. Maybe people are too shy to go on the chat room. So the first one is how long does it take to go through all the filtering tools before it's determined whether something is positive or to block or malicious? So we went through several steps along the way to determine if it's positive or block. And so how long does that whole process take? Is it real time? Does it sit in a database, or what happens?
That's a good question, because it's actually quite a complex operation, but it's instant. So the idea here is that your end user does not know what's going on behind the scenes, but this has been broken down just so that we can kind of understand the mechanics that power this, but it's instant. This is imperceptible to the end user. Great.
And then it is fair to say we're kind of looking at the DNA pattern of these malicious attacks as opposed to maybe just headers or a point system. To determine what patterns are going on out there. It's more almost like looking at a human DNA scenario as opposed to maybe just points on a malicious attack. Does that make sense?
I mean, yeah, absolutely. I mean, the idea, the magic behind this is that rather than taking a binary decision in a very static way, so matching, you know, a request comes in, you look at a database, you try to find something that matches, and then you take a binary decision. The idea is to say that different people use different applications differently, and the way in which they use the application is constantly changing. So we have a look at lots of parameters around that particular request each time, so that we build a much richer score with which to take a decision.
Great. All right, I have one more if you want to take one more. So sometimes at the front end of an attack, like the first single point of entry into the marketplace, the attack may go through and, you know, nothing's 100% per se, but if it goes through, what's the remediation of that then? Let's say we saw an attack start, maybe we didn't see the first one go out, but then we caught it. Can we then remediate the one that we said, oh, we saw that go out, let's go grab it?
That's an interesting question. That's probably a more technical question for the product manager. But I can certainly, if you ping me the person who's asked that question after the webinar, I can find out and let you know. But the idea here is, sure. Again, you know, we've also got far behind this. We've got Threat Cloud, of course, and the ability to, you know, understand across the solution suite what attacks look like. But again, we're not running a signature matching exercise, so this is extremely precise.
Yeah, I think the point of this is it's not just one tool or one item that's doing this. We have a whole system being involved in this process. It's not just one little item, right? It's a whole company. It's a whole entities and resources that we're using to fight this, not just
Yeah,
one
actually,
single.
no, that's actually a really great point. So I think that the thing to keep in mind here, and I don't want to go too deep down this rabbit hole because it will become a much broader conversation, but when we talk about workload protection within CloudGuard, so we talk about workloads, of course, being your cloud applications. So there is a lot of smaller, extremely effective players who perhaps have disparate solutions for different parts of workload protection. So you might have a customer who has a really good, container security solution, which is great. You might have a customer who also has an excellent security solution for their cloud native services. What tends to happen is that the application layer stuff is somewhat neglected and there's some kind of legacy WAF protecting the application layer. And so the beauty of taking this kind of solution from CloudGuard is you have that unification of all of the pieces of workload security from, your sort of cloud native, the network stuff, to the containers, protection for the serverless functions, the virtual machines, and the application layer and associated APIs. And suddenly all of those fragmented bits of security that's trying to protect, the dozens of applications and the millions of microservices is all unified in one security platform. And that's, very unusual. I think we're one of the only, if not the only player in the market who's going to be able to say that we can actually protect all of those things in one consolidated platform.
That's a great point. All right, thank you.
Great. So again, if anybody has any questions afterwards, please feel free to reach out. Look out for the campaign in the box, which is coming to you via our channel team next month. And thank you very much for joining us.
Great job. Thank you.
Thank you, Yafa. Thank you, Paul. Just a reminder again to our partners still on the line, please log this as an activity and engage, and you can receive points for it. And we will be sending out the recording of this webinar to all of you on this call. So thank you again, everyone, for your time today.